How's it going, guys? Matt Ader here. Going to be starting a new series of Unreal Engine tutorials. I've noticed on YouTube there's a lot of blueprinting tutorials and not enough C++ ones, so I figured I'd put some out there for you guys if you're interested in doing C++ versus blueprinting. So if you clicked on this video, you're probably looking on how to program your character to move or something like that. So let's get right into it. We're going to start a new project here. We're going to go into games as our category, and then we'll go next. So there's all these different templates that we can choose from, but for this we aren't going to use any template. I prefer to go blank. It's all your own original code, and you can present that as your own original code too. Even if you copy it from this video, you're still learning. That's what matters. Okay, so in project settings, we're going to choose C++. Ray tracing disabled. You can set whatever quality you want. I'm going to do maximum. You can do scalable. That allows you to change your settings within it, but I'm just going to do maximum for now. And then leave it as no starter content. So I'm going to go in and name it to third person tutorial. Okay, third person tutorial. Perfect. So I'm going to hit create project. What this is going to do is this is going to generate a U project and a Visual Studio file set for it. I'm not great with words, so I may misname some things. I may even skip this whole part because this takes a lot of time. Okay, so what you're going to do once you're actually in the editor, you're going to click this little button right here to open up the Show the Sources panel. You're going to click C++ classes, third person tutorial, or whatever you named your project. You're going to right click and do new C++ class. We're going to choose the parent class as character, and we're going to derive from that for the child class that we're creating. I'm going to go ahead and name this just player character. So now this will be called player character class. We will go create class. So what this is basically doing is it's going to generate your C++ and your header files for this class, and then it's going to do a hot reload. Okay, so the compile completed. You'll hear that little annoying noise when it's completed. So then you'll go into this and you'll hit reload all. Make sure you always save before you do a hot reload. That's what that's called, a hot reload. Okay, so now what we're going to do, we're going to go over to the header. This is the header right here, .h, and we're going to set up a few characteristics. So under our public class, we're going to make a few U properties that can be accessed from anywhere. So we're going to say U property. We will say category. This is what it'll show in the Unreal Editor, equals camera. We will say visible defaults only. Blueprint, read write, and we will make a meta for it. We will say meta equals allow private access equals true. You don't need to put a semicolon as you usually do, but you will for the next part with your forward declaration. So we're going to forward declare our spring arm class. So we will say class U spring arm component spring arm component. Perfect. So we're going to close that off with our semicolon. Basically what we're doing is we're declaring a pointer to our spring arm component class in Unreal Engine, and we are making our own component inside of player character of that. So we're going to go ahead and copy that, paste it. We're going to change spring arm component to U camera component, and we will change this name to camera component. Perfect. So then what we're going to do from here is we're going to make some floats. So we'll say U property, edit anywhere, blueprint read write. Say our first one we'll say is float speed. So you can go ahead and copy this because we're going to use this same type of style a couple times. So we're going to say float speed. I'm going to go in and do float health, float maximum health, and we're going to make a boolean. So these are for multiple reasons that we're doing these, and I'm just setting us up so that we can exceed with future tutorials as well. So we'll say B is crouching. I'm going to preface this with B because I'm changing the type from a float to a boolean, which basically means it returns true or false. So now we have our speed, we have our health, our maximum health, and our crouching. Health and maximum health are going to help when we make a heads-up display. Our speed is going to be for controlling our animations, and crouching for animations as well. So now what we're going to do is we're going to move down to protected. Public can be called anywhere. Protected can be called within player character or from classes derived from player character. So now we're going to go under begin play. We'll add something, we'll just call it movement as a comment. So now we will add a void which returns nothing. Void move forward. We'll say float value. So it's going to take in a float value as its input. We'll make another one, void move right, float value. This is going to be these values are going to be our modifiers for that. So now we'll do crouch, void on crouch begin. Make another one, void on crouch end. Perfect. And we are all set with our H, our header file. So you can go ahead and create the definitions for these inside of your C++ file. So we're going to go ahead and jump over. At the top, there are a few includes that we're going to need to properly construct our class. Always leave your first include at the top. So the one of your header file, always put that at the top. That needs to be compiled first. So we will say include we will say include game framework spring arm component, include camera component, include Kismet, gameplay statics, and include game framework character movement component. These are the included libraries we will need to use. So now we're going to go down to our constructor. We're going to leave the tick equals true, and we're going to go ahead and set our variables. So first we're going to say speed equals 0.f. We're setting it to 0. And we're going to say maximum health equals 0.f. Health equals maximum health. B is crouching equals false. What we're doing here is we're basically setting up all our variables so that they can be used to whatever they are set within the editor. If you want to start something crouching, it will start crouching in the begin play. In the begin play down here, what we can do instead is we can say, just as a check, is health equals maximum health on begin play to make sure that if the maximum health is edited at any point, or this, then it will set the player to start with full health. That's just a check you can do. You don't have to do this. If you want your player to start damaged or something like that, you can leave that. So now we're going to move down to move forward. Okay. We're going to check to make sure that our value is not 0. So we're going to say value does not equal 0. We can open the statement. And next we're going to check to see if the player is currently crouching. So if B is crouching. So if the player is crouching, we are going to slash our value in half to return the value as only half of its original input. So we move at only half of the original rate we were going to. So we can add a comment here saying that. Oops. If crouching, cut movement speed in half. So we will go down here, make some room, apply movement. So we will say add movement input, get actor, forward vector, and value. Perfect. So now what we can do is we can copy this whole section, go into move right, add it in, change forward to right. So now we're doing the right vector, which is perfect. Now we will go down, we will do on crouch begin. We are just going to set our B is crouching to true, and we are going to call the character movement components crouch and pass in true for client simulation. Same thing with the end. We are just going to say is crouching is equal to false, character movement component uncrouch, client simulation true. Perfect. So now we're going to move down to our tick. As the player moves, we're going to need to increase the speed so the animation can keep up. We're going to need to get the velocity of the player. We can do this by declaring an F vector, a vector of 3 floats. We can call it velocity and make it equal to the return value of get velocity of the player controller. So now the problem is we can't make speed equal velocity. It's not a thing. If you see with the error here, velocity is an F vector, speed's a float. We need to convert this to one value. What we can do is we can use size. This will bring us the length of this to give us a constant float value. Every tick, it will be accurate with how fast they are moving. Lastly, all we need to do left in the C++ document is we will need to set up our player input component. So here we will check if input is valid. We will do this by saying check player input component. Perfect. Okay, so now we've done the super player input, which basically calls the A characters input component. So now that that's set up, we can set up our mouse axis. We will say player input component, bind axis, look up, this. So we're passing in this as the object that we're applying this translation to on the axis. And then we're going to say a reference to a pawn. And then we will say add controller, pitch input, and then cut that off. So the pitch input is the up and down of the player's controller. We will copy it, paste it. The next one we will call it turn, which is the left and right. We will make turn equal to yaw, the yaw input up and down. Perfect. So then we're going to move down to movement actions. So we will say player input component, bind action this time, not axis, action, jump, i.e. pressed, this, and we will say a player character. Oops. Sorry, my bad. We need to put the and symbol first. A player character, which is our class, colon colon jump, which is already defined for us. Then we will take this, copy it 2 more times. We will change the second one to say, instead of pressed, released. We will change both of these to say crouch. So we'll change both of these here to say crouch. This first one, we will change it from jump to, we will call our player character, whoops, not crouch, on crouch begin. The second one we will do on crouch end, that function that these 2 functions we declared. Perfect. So on pressed, we will begin our crouch, and on released, we will end our crouch. If you want to make it toggled, so when you press it, it toggles between crouching and not crouching, you will have to define that differently. This is just for holding. So now what we will do is we will do our last 2, which is movement axis. So we will say player input component, bind axis, move forward. We will pass in this. We will pass in a player move forward that we defined before. You can now copy, paste it back in. We will change move forward to move right, and we will change the function to move right that we defined before as well. Perfect. So all of this is saved. Make sure you save it all. We're going to go back up to the constructor to finish off adding our last components here. So what we're going to do here is we're going to create spring arm. We're going to say spring arm component equals create default sub object u spring arm component, and add a flare text just to define it in the editor. We will say spring arm. We're going to attach the spring arm. So we're going to go spring arm component, set up attachment, and we're going to attach it to the player's capsule component, which is for collision. Why isn't that usually? Get capsule component. Oh, spring arm. Oh, I need to I need to include capsule. Whoops. That's one more thing we need to add. Include components capsule. Component.h. That should do it. There we go. So now capsule component is working. So now we're going to set defaults. So we're just going to say spring arm component target arm length equals, we will say 200.f for our default value. Okay, so now we're going to create our camera. And we will say camera component equals create default, just close that, create default sub object u camera component, add our flare text, so text, and we'll call this just camera. Perfect. The last thing we'll need to do is we will need to attach the camera component to our spring arm. So one side of the spring arm will be attached to the capsule of collision, and the other side will be attached to the camera. This will allow the camera to move more modular with the capsule rather than just floating. So now that everything is saved, double check, we have our includes, we have everything defined, we're good to go. We'll hit the debugger.